Welcome to Part 8 of Unbinding Prometheus, how generative AI liberates computational thinking from coding. In this final segment, I explore how higher education must evolve to teach AI proficiency and prompt-guided computational thinking as a universal skill, shifting focus from manual coding to creative collaboration with AI. I also highlight the need to balance innovation with ethical responsibility, ensuring students harness AI's power while upholding trust, safety, and human-centered values. As we close this presentation, let's zoom out and reflect on how generative AI and the growing commoditization of computational thinking are reshaping both higher education and lifelong learning. Interest in computer science has surged and receded in cycles over the past 5 decades, mirroring society's shifting assessments of the value of computing proficiency. We're now entering a new era where generative AI extends the reach of computing to anyone with curiosity and questions. The new computational literacy is not about coding itself. Instead, it's the ability to translate human intent into forms that machines can reason about, effectively, ethically, and creatively. In this transformation, computational thinking is evolving from a specialized discipline into a universal language of modern problem solving. So, should everyone still learn to code? The answer is probably, but not for the same reasons and not in the same way. In the old model, frustrated coders wrestled with obscure syntax and cryptic errors. This model is giving way to a new kind of fluency where the programmer evolves into a prompt engineer, someone who communicates ideas clearly to intelligent systems by collaborating through language, logic, and creativity. The essence of programming and problem solving remains, but the medium is shifting from curly brackets and semicolons to dialogue and design thinking powered by generative AI. This slide illustrates what I call the pyramid of AI proficiency, a modern echo of Maslow's hierarchy, reimagined for the age of intelligent computing. It shows that people across disciplines will engage with AI at different depths depending on their goals and responsibilities. At the foundation lies AI literacy, where everyone's journey should begin. Every student, no matter their field, deserves the chance to understand what AI is and how it works, its capabilities, its blind spots, and its ethical boundaries. This isn't about coding. It's about cultivating awareness, skepticism, and sound judgment. AI-literate learners can tell when these tools help them think better, when they're leaning too heavily on them, and when human reflection must step back in. In essence, AI literacy is not only technical, it's civic, ethical, and deeply human. The middle tier represents AI fluency, the stage where learners and professionals move beyond awareness to mastery within their own domains. Here, the goal isn't to write code, but to communicate effectively with intelligent systems through prompts, data, and agentic workflows. This is the realm of AI-augmented thinkers, prompt engineers, computational creatives, and researchers who use generative tools to accelerate discovery and creation. A computational chemist, bioengineer, or digital humanist may never touch Python or JavaScript, yet they must know how to guide large language models, test ideas rapidly, and generate insights responsibly. AI fluency is about speaking the language of intelligence itself, using it to extend human reach, imagination, and capability. At the summit lies AI mastery, the domain of those who create the systems that power our intelligent world. These are the computer scientists, engineers, and developers who design, train, and rigorously test the algorithms and platforms that make generative AI possible. AI masters don't just build models, they shape the foundations of modern technology, from spacecraft control systems and biomedical devices to the digital infrastructure that keeps society running. AI mastery demands deep expertise in coding, systems architecture, and validation. It's not the path for everyone, But it's essential for everyone's future, because without these builders, the rest of the pyramid wouldn't hold together. Just as people can understand where their food comes from without being farmers, they can understand computational thinking without being coders. But we do need a vibrant ecosystem across all three levels. People who are literate enough to use AI responsibly, fluent enough to apply it to innovate their workflows and domains, and masterful enough to build and validate the next generation of trustworthy intelligent systems. The future of education and of work will hinge on how well we help students and ourselves find our place on that pyramid and climb as high as curiosity and purpose will take us. Learning must now move beyond passive use of AI toward active collaboration. Students should learn to craft prompts that shape how AI reasons, interpret its responses critically, and refine those outputs into stronger insights. At the heart of this emerging skill set is computational thinking, not as a niche technical field, but as a universal literacy that empowers learners to reason, problem solve, and co-create intelligently with machines. If we want students to collaborate with AI safely, we must actually teach them how to do this confidently. Ironically, we invest hundreds of hours teaching teenagers how to drive cars safely, but barely minutes showing them how to use AI safely. When my son learned to drive several years ago, he logged 40 hours in the classroom and 100 behind the wheel under close supervision by certified instructors and adults. However, his high school's AI instruction was maybe 5 minutes at best, often from teachers who'd never used these tools, but who warned, "Don't use AI, it's cheating, and will rot your brain." Meanwhile, many students already live in an AI-suffused world, scrolling, chatting, and creating with intelligent systems every day. But to prepare them for the future, we must move beyond passive use toward active understanding. It's time to teach them not just how to use AI, but how to work with it and use it wisely as creative partners in an age defined by human-AI collaboration. So, let's now discuss what we can do to prepare for our AI-augmented future. We must start by recognizing that programming itself is crossing a bridge, from painstakingly coding line by line to clearly describing what we want in natural language. Traditional coding can trap us in syntax errors and mental gymnastics, while natural language programming opens a new frontier of collaboration. Now we can say, generate a function to parse this CSV file, or build a RESTful interface for my to-do list app, and AI handles the mechanics. The syntax fades away, revealing the true core of programming: clear logic, structured thought, and human creativity guiding machines instead of the other way around. We also need to bring AI-augmented development environments into our classrooms. Tools like GitHub Copilot, ChatGPT Codex, Claude Code, and Windsurf are becoming as indispensable to developers today as compilers once were. Tomorrow's programmers won't just write code. They'll co-create it with intelligent partners that autocomplete logic, generate tests, explain functions, and debug on the fly. Even in courses that don't explicitly teach AI, students should learn to work fluently with these tools, because in the modern workplace, hiring managers won't ask if students can use them. They'll just assume it. However, there's a real risk on the other side of this transformation, leaning so much on AI that our own skills start to fade and our minds burn out from over-automation. Developers who let AI do all their thinking risk becoming passengers instead of drivers, capable of vibe coding, yet unable to debug, design, or truly understand what's happening under the hood. Some developers are even going as far as to stop using AI code editors because they feel the magic of AI is eroding their mastery when used without self-discipline. While I personally don't subscribe to this viewpoint, the goal of AI should always be to amplify your talents and skills, not outsource them. We must also recognize and embrace the coming reality that computational thinkers will soon greatly outnumber traditional programmers. The image on this slide captures that transition. The old temple of coding on one side, the new hall of prompt engineering on the other, connected by a bridge of natural language. The next generation won't write software line by line. They'll guide AI through reasoning chains, test-refine loops, and iterative improvement. It's a thrilling and sobering shift. More people than ever will wield computation to solve problems once tackled through bias or intuition, but only if they understand the logic beneath their prompts. Otherwise, that bridge could collapse under its own convenience. To make this transformation sustainable, we must bring the same rigor to prompt engineering that we apply to software engineering. Testing, maintenance, version control, and project management now belong inside the AI workflow. Too often, prompting is treated like casual conversation, but meaningful progress demands structure and discipline. Prompts should be managed like code, tested, refined, versioned, and validated for reliability over time. That's what I call prompt engineering in the large. Significant R&D is still needed to mature this type of prompt engineering, which is also simply known as promptware. While prompt engineering in the small equips individuals with reusable patterns and best practices, scaling to resilient, mission-critical AI systems demands more than a toolkit. It calls for a full engineering workbench with drawers labeled testing, version control, configuration management, prompt templates, and prompt linting. The aim of promptware is to help teams harness AI tools across long, evolving project life cycles through shifts in people, platforms, and priorities without accumulating mountains of technical debt. Building responsibly with AI requires disciplined workflows for testing, versioning, and auditing, not just quick vibe coding. Generative AI can accelerate progress, but without engineering rigor, it can just as easily accelerate chaos. So if coding was the defining literacy of the past several decades, then prompt-guided computational thinking is fast becoming the electricity of the future. Omnipresent, indispensable, and yes, occasionally shocking. Prometheus would grin knowingly at hearing all this. He'd recognize the spark. But he'd also remind us that every fire needs tending. As we harness this new creative power, we must keep our eyes fixed on trust, safety, and ethics, the moral circuitry that keeps innovation humane. Before we close, if you'd like to explore these ideas further, I've shared many more talks on my YouTube channel, Douglas Schmidt, including how we're future-proofing students at William & Mary, how AI is reshaping higher education, and how software engineering itself is evolving in this new era. Check out the videos in my Generative Augmented Intelligence playlist when you have a chance. Thanks for inviting me to visit and for listening to my talk. I'm happy to take any questions you may have.